AWS Loft Talks.
So hi, my name is Rob Zazueta. I'm on the strategy services team at Mashery. We're an Intel company. Mashery is actually an API management company. We were purchased by Intel about 2 years ago, and what my team does is it helps folks figure out what are their APIs going to look like, how they're going to be successful with them, and ensuring that the API program they put out there is well aligned with the goals of their business. And it's true that while we're talking about Mashery, we're really talking about web services. So we're actually talking about more about the cloud type stuff. And we are hosted very heavily on AWS, and rely on them very heavily for getting things up there. That's kind of where most of our stuff lives. But when we're talking about the IoT, we're still talking about APIs in general and the same kind of large cloud deployments with all that data coming out there from the edge clouds and the edge devices so that we can collect that data and make use of it. The first thing that's really important to remember is that the IoT is not really something new. We've been talking about this for years. M2M is not new. How many here remember the X10 pop-up ads from the mid-90s? This is not a new thing, and folks are still trying to program and figure that stuff out and build it out. What's making a big difference now is the fact that it is cheaper to have these edge devices, more importantly, to have these edge devices closer to the sensors themselves. So while I might have one edge gateway in an installation, I might actually have multiple edges that report to that edge gateway, which then report to the edge cloud, which then report to the old or the new cloud. And one of the things that, I work for Intel, so I've got to talk about this. One of the things that does make this easier are these smaller devices. This is an Intel Edison. It is an Atom processor with Wi-Fi and Bluetooth. It sucks up 3.3 volts. This is actually a prototyping board. The reason I put the picture up here is so you can see it better because it's hard to see in my hand because it's so darn small. But this is an incredibly powerful device. It's a computer. It's got full Yocto Linux running on it, and I can actually install Ubuntu and a bunch of other things. I can install some packages on here. I can program directly to it. I can run Node off this, so it becomes a server. It's really impressive. And these are the kind of devices that are now coming on the market, and they're much cheaper, and they're much easier to use, and these are the kind of things that people are building off of. So when we talk about the IoT, we've got to remember, this is not new. It's just getting better because we're able to do more with it. So when we talk about the APIs, what we're talking about is command and control over these devices. When we talk about command, we're saying I need all the information that I can possibly get so I can make the right decisions. And we're talking about control, we're talking about communicating back to those devices to tell them if they're an actuator or something along those lines, so they can be changed, or their state can be changed, how to do that. And that's what APIs are intended to do. So really there's three things that we're looking at with APIs right now, and the Nest is a great example. So this is really oversimplifying it, but I can extract data from the device, find out what the current state of that device is. I can send it some data that might program it for the future, or might tell it to do something, or tell it to act if there's some kind of local runtime on it that can listen to that, and listen to its sensors, and basically program the logic. And then finally, I can change the state of this thing dynamically. I can tell it to change temperature. I can tell it to turn on. So if it's following a certain program and I want to interrupt that program, I can do that immediately. This is what we're able to do right now with a majority of the APIs that are on these devices that are coming out there, but of course they're all very fragmented. In reality, what we're really seeing is that this is kind of the current state. So you might recognize this is the Philips Hue. And if I have my phone, I can go ahead and tap it and turn it on. Ask somebody to do it for me. See, rather just have the switch turn on itself. That's not interesting. It's kind of a boring use case. So I can turn on a light. But this is the kind of stuff that we're seeing in the consumer space right now. Well, the Philips Hue can do more than just this. It can do so much more. It can also change colors. So, I'm sitting down with my wife. We're going to have a romantic evening. Maybe set some mood lighting, get the berry white going on, figure out what color I want. All right, this is kind of interesting. I don't have to get off the couch to do this. I can do this from my phone. I can control it from anywhere. All right, a little bit more control over my devices. Still kind of interesting, but the use case isn't quite there. What about the next use case? What happens when I connect more than one device together? So this is kind of my situation. I live in a place where my washer dryer is out in the garage. And if I'm doing a lot of laundry one day, I don't necessarily know when the cycle ends because I can't hear it. What happens when I connect a device to another device? This light that all it used to do was provide light. Then it became something that I could do to change colors. Now it's a notification device. That's interesting. It's the interaction between the devices that really start creating that power in the IoT. And again, like I say, this is nothing new. In the consumer space, we're starting to see it emerge. But in the industrial space, it's been there for quite some time. I hate talking about disasters in these kinds of talks, but I'm going to bring it up anyway. A couple years ago, when the Malaysian air flight disappeared, this was a big story. For about 20 minutes after the cockpit went dark, the Rolls-Royce engines on that plane were still communicating with the ground. Lots of engines on the planes that you fly when you go on your trips, they are connected to the ground. They've got tons of sensors in them, and they're constantly communicating. Upwards of 500 gig to a terabyte an hour per flight hour. They're constantly communicating with the ground. They're sending reams and reams of data so that folks down below can start looking at predictive analytics to see, well, when's this plane going to fail? What kind of maintenance does it need? Is everything operating appropriately? I can start connecting that to its temperature, its location, the kind of weather, the kind of salt it's been exposed to. This is happening now and is a big part of the industrial internet. It's a matter of taking this and moving it down the plane and having it in the consumer devices and pretty much everywhere else. And everything that drives this exchange is APIs. Right down from the point where the chips are communicating, where the sensors are communicating with each other, those are using I2C or SPI. Those are still API protocols. They just happen to be on the wire. And then across from that, they're sending that data back down, probably over a series of cellular networks that are probably part of the avionics systems that are already in place. And they're not necessarily using HTTP. They're going to be using existing protocols that are there. But they're still communicating. These are still APIs. And so we need to think about these things. We need to think about how these things are communicating as we go. Another big example that I love and what IoT and APIs have done to transform a company is Wayne Industries. I encourage you the next time you go to fill up your car to go take a look and find the badge that indicates who created the pump. Wayne Industries is known for making gas pumps, and they've been doing it for about 130 years. And back in the old days, like folks who collect them, this is what they collect. You see these. And this was their business. They built these pumps. They built the parts to replace and maintain them. That's how they made their money. And now when you go to the gas station, this is what you see. These are amazing devices. They're basically computer-controlled pumps. They're still made by the same company. Wayne has actually converted from a pump company to a payments and services company, because this pump is connected to so many other devices at the gas station. It's connected to whatever kind of payment you want. This is just cell phone payment like Apple Pay or something like that. But it can really be off my watch. It can be whatever comes down in the future. They've got the readers on the pump. They still take credit cards. You get advertising at the pump now. I don't know if that's necessarily a good thing or not, but these devices that are reading based upon some of the history that you've done or what they see is going on around them, they can target advertising based on the context of you being at that pump. All this data, of course, is being fed into analytics systems, so they can do some kind of predictive analytics to figure out when they need to come out and do more gasoline, figure out on hot days, can they raise the prices, lower the prices, all that kind of stuff. And then, of course, it all comes back into the POS system inside the main office. So when we talk about this, and we talk about the POS system, they're all communicating to each other. All these systems are constantly communicating to each other. And they're, again, using APIs. Any number of different protocols. This is probably a proprietary set of protocols that they built in order to communicate. And they're communicating over Bluetooth, Wi-Fi, wire, whatever the case may be, whatever makes the most sense for that location. When we're talking about the installations of these devices, these are going to be smaller networks that sit in that location individually, and they will communicate with each other. And they could just be a mesh network, they could be gateways communicating. Regardless, we're still talking about how is that information being controlled, how is that being sent, and how am I able to command and control the data associated with these devices. APIs, once again, are the answer. So this is kind of interesting because this is inside the gas station itself. But let's assume that we're using the POS as the gateway. That's the thing that's connected to the internet. That's where all the main data is being collected because the money's being collected there, etc. That's going to start going out and communicating to a bunch of other devices. As more and more devices, as more and more gas stations come online, there's going to be more and more devices across the United States, all communicating back probably to some central server that's going to be growing as things grow. More data comes in, that server's going to have to collect that. So now we're not just talking about the APIs and the data that's going to happen within that smaller network. We're talking about the data that's actually being collected by all of these things, all being connected to each other, connected potentially through central servers. And that represents a tidal wave of data that is coming down the line. And the best way to handle this tidal wave of data, the savior for us when it comes to this tsunami of data as it's coming up, whether it be from the individual sensors into the edge gateways, from the edge gateways into the central servers, from those central servers communicating with other applications all the way down to your phone, down to your watch, down to every wearable that has some kind of user interface. That's a lot of data. And what's going to save us is well-designed, well-managed APIs. All the way down from whether we're talking from server to server, whether we're talking about the individual chips communicating with the individual devices, well-designed, well-managed APIs are going to be what save us. So what do I mean by this? When we talk about well-designed APIs, I, of course, come from a RESTful background. And I don't like to think about REST as solely an HTTP protocol. You have to separate it from HTTP. It's heavily informed by it, don't get me wrong. But it's the architecture, what I consider the RESTful architecture, that is more interesting. The RESTful architecture means that what we're focusing on are resources, relationships, and representations of data. So when we talk about resources in terms of IoT, those are going to be either some kind of a port, if it's a larger system, or more than likely it's going to be the device itself. The temperature sensor, the light bulb, whatever the case may be. And it's going to want to tell anybody who asks, or it's going to communicate on a constant basis, what its current state is. And there needs to be some level of data associated with that. It can't just be spitting out a float and expecting you to know what that float means. You should design this in such a way that everything I could possibly need to understand what this device is saying to me is being communicated constantly. It's just a few extra bytes of data, which, yes, that does add up over time as more devices come down the pipe. But I think it's worth the cost of having that there so that I know this float actually represents the temperature in Celsius associated with a device of such and such an ID. I don't really need to know, as the device itself, much more than that. When we talk about relationships, if that device is part of a group of devices, or we're even talking about it communicating back to the edge router, that device itself may not know anything about anything else. It may only know about itself, and that's fine. And when that device communicates to the edge router may know about the handful of devices that it has access to. And when it communicates to another edge router or another server or another device that's reading that stuff, it should be communicating to them saying, here's what I have available. Here are the kind of things that you can ask me for. That's discoverability, and that's what the relationships really help with, is saying, what else is there? What else can I do when I get to this point? Communicating that means I can drop those sensors, I can drop those gateways, and if it's done in a fairly consistent way, I can immediately have a system that discovers what's going on and can start adapting accordingly. That really helps when we start onboarding these systems, onboarding these devices. And then finally, representations. That means, how is that data formatted? Now, typically when we're talking about this with HTTP REST, we're talking about MIME types. So I can come back and say, it's not enough to say, I'm sending you JSON. I really want to know, what is the format of that JSON? It's application/JSON, semicolon, vnd.example.resource-name.v1, right? That's a much better way to do it. Because now as I get that information, I can say, oh, okay, what do I do with this? Oh, I don't recognize this MIME type. Is there a place where I can find the information and get the definition? Oh, okay, there's the definition, so my application can adjust accordingly. That same kind of information on a much smaller scale, it's very, very heavy when we're talking about HTTP RESTful APIs and MIME types and content types and stuff like that. But there's no reason we can't shrink that down and give the same kind of information, even if you get it out of band, even if it's just pointing me to say, I'm a temperature device, and I'm this kind of a temperature device. It's all it needs to know. And now I know based on the system, okay, if I send that up here, it tells me what I can get from that temperature device. Ah, that's what this represents. This float is not just a float. It's actually in Fahrenheit, and it's down to the 6th decimal place, or whatever the case may be. So having that information and that representation is key. And when you've got the larger devices that have more processing power, they can actually adjust the representation based upon the needs. So if it's just the edge gateway and they want to get all the data, maybe I give them the full set of data. If I've got a mesh network where I'm communicating with a gateway, but I'm also communicating with other devices, but they can't handle that much, I might send them a smaller representation that's only the tiny bit of what it is. For that matter, I can use these same representations to change the style of the protocol that I'm using, or the style of the API that I'm using, potentially over the same protocol. Or I could switch protocols depending on if there's a good handshake that can happen there if it's small enough, right? So that's when we talk about REST, I'm talking more about the architecture and taking that and shrinking that down. When we're designing these APIs, to me, these are the three things we need to focus on. When we talk about managing APIs, what we're really talking about is scalability, security, and support. So when we're talking about scalability, it's making sure that whatever you've got in place can scale vertically across things. So we're talking about one small installation within my house. Scaling that out, it might be 10 devices. It might become 50 devices sooner than you know. It might become a couple hundred devices. I've got to make sure that edge gateway can handle that. I want to make sure that the communication, the latency is low, the communication is strong, it's not knocking over my gateway. I don't want to have folks at home trying to figure out how to reboot the gateway just because we DDoSed it with all the sensors that are in my house. And that gets even more important when those different gateways start communicating back to the central server. You want to have solid API management on that central server so you're not knocking it over. You're able to scale horizontally. You're able to keep things up and running. And good management allows for that. Security, when we're talking about security, talking about the identity of the devices. We're talking about the identity of the people who own it. We're trying to make sure that you got the physical security in place, but also when I'm communicating back and forth, if we don't have crypto in place because it's too hard to do, what other security can I put in place? How do I ensure I'm only sending the data to the places, to the devices, to the applications that need to be there? How do I make sure that only those devices and those applications have access to what they are able to get and make sure that the other folks aren't able to inadvertently get in it? So that's where we talk about API keys and that kind of thing, but when we're talking about IoT, it goes deeper than that. When you've got a small network that you can work with, it's not as big a deal. Physical security becomes a bigger issue. It's when that starts leaving those smaller installations that becomes crucial that you start putting these things in place. And then support. Part of it was the discoverability. Part of it is having some support structure in place so that if I get a content type, I know what it means, or if I get some kind of message, I know what it means. More importantly, making sure that the developers who are taking advantage of these APIs and taking advantage of the programming of these devices have the documentation they need, have a portal that they can go to, that they can work with. One of the things that I hear often is that developers are lazy. And if you're a fan of Larry Wall, you know that he has his 3 virtues of the developer, which is laziness, hubris, and impatience, which is really just a negative way of saying that developers are actually busy. They need to get things done. They've always got technical debt. We all have technical debt. Developers aren't lazy, they're busy. Anything you can do to help them get their job done faster is going to help you maximize their potential faster, whether it's your internal developers, partner developers, or an open ecosystem. So again, I say the real power of Internet of Things comes when devices talking to each other. Let me tell you the secret of actually why I'm so involved in APIs and why I love them so much. It's this part in yellow. It's when anybody can program those interactions. This is important to me. We're right now talking about APIs and focusing on developers. We talk about the developer experience and developer communities. When you build and design APIs, whether on the large web scale or on the small device scale, and you think in terms of making sure they're discoverable, making sure that they can drop in and anybody can read them, making sure that you're following the right protocols, you can actually create systems where folks who are not programmers can actually use interfaces that discover this on their own, and they can start creating their own interactions. So we're all pretty much familiar as developers with the concept of Visual Studio. Visual Studio is one of the best IDEs on the market. I don't care what you say about .NET and Microsoft Technologies. This is the one thing they nailed. Because if I'm going in and I'm doing something in C# and I start typing, it starts filling things in for me. It makes sure that when I put in there and I've got a variable that I've already set as a string and I try to go into a function and I set it, that function doesn't take a string, it takes a float. It immediately catches that as a context error. That's incredible. That has to do with the fact that it's going through and it's going and doing inspections in the DLLs and the code that's already there, and it's tracking this as we go. That discoverability is something it's learning as things go, but there's also a lot of that functionality that comes as part of building that library, so it is exposed in such a way that Visual Studio and other IDEs can take advantage of that. Imagine when we have APIs that can do exactly this. What does that enable? One of my favorite sites, If This Then That, okay? If is pretty incredible. If This Then That is a site, if you've not checked it out, I strongly encourage you to do. It's very simple. If something happens, some API this happens to be connected to, is triggered with an event, the state reaches some point, something happens, I get a message, an email comes in, somebody tweets with my name, then I want some other action to happen. If a tweet comes in with my name, I want to receive a text message, or I want to retweet that, or I want to store it in a database. Very, very simple concept. If this happens, then do that. It's event programming. But it's done in such a way that it's a website that practically anybody can use. I go on there, and as long as those APIs are set, I can click and I can choose the data that I want to act on. And then if I can make some kind of an update, I can send another call to an API and do it from there. It's really incredible. This is to me, the programming of the future. because we're getting to the point where folks don't have to write a line of code. And as of right now, the way that IFT works, they have to build a bunch of adapters for APIs to make this work. They actually have to go out there and build the microservices off those APIs that'll enable this to happen. With well-discoverable, well-built APIs, they wouldn't need to do this. Somebody asked about the kinds of user interfaces we're going to start seeing in the future in our homes to control these things. These are the kind of interfaces I expect to see. Because you can't expect to have a team of developers going in and constantly rejiggering the kind of stuff that's happening in a factory. I mean, we've got that now, but why not give that control to the product managers? Why not give it to the folks who actually know how to do this? Why not give them that power? This is a pretty simplistic interface. A more complicated interface is something like the Scratch programming language. Still visual, sticks more strongly to a programming paradigm. For example, there's this concept of defining variables. There's this concept of repeat structures and wait structures. This is just a straight up stack of information. But again, I can go in here, I can see what the different parameters are that I can pull, let's say, from a particular device. What can I do with this? What does that parameter mean? I can set that parameter. I can do an if that parameter equals whatever. And that's all preset in here. Very visual, very easy for me to see, and I can start programming incredibly complex interactions. We're going to continue to be focused on developers. I'm not looking to put the guys out of a job. But they should be focusing on the hard stuff. They should be focusing on building those UIs. They should be focusing on making sure those APIs are discoverable, are strong. They should be focusing on that kind of stuff. And let the business logic move up to where it belongs, the folks who control things. And when I say that, what I'm really talking about, what I'm really thinking about is someone like my dad. So this is my father. He's 70 years old. He's been on the computer now for about 6 years. When IoT comes to his home, I want him to be able to create those interactions. Back in the day, though, he was a forklift driver for 30 years. If there was something going on that floor, he was a warehouse worker. He knew better than his managers. He knew better than the IT team. Why don't we give him that control to go in and say, when this happens, let's do this? We can move that up the pipe. Well-managed, well-designed APIs from the chip level all the way up to the web server level can help with this. Designed for discoverability, designed for flexibility, designed for scalability, we can get there.
AWS Loft Talks.